All right, let's dive into some of the invisible chemistry that honestly runs our world. We're talking about acids, bases, and salts, and it all kicks off with a super simple everyday mystery you've probably never even thought to ask. Think about it. You've known this your whole life, right? Why does a lemon make you pucker up with that sour taste, but a bar of soap feels all slippery in your hands? The answer to that little mystery, well, it opens up this incredible story about what's basically chemistry's ultimate power couple. Okay, so to get to the bottom of this, we've got to shrink ourselves way, way down and step into the world of ions. These are the tiny, charged particles that are the real movers and shakers in the chemical world. Seriously, they're the hidden players behind pretty much everything we're about to get into. So a lot of the stuff we're going to be looking at, think table salt or baking soda, that kind of thing, they're what we call ionic compounds. And you can just think of them as this perfectly matched pair. One positive ion, which we call a cation, and one negative ion, the anion, stuck together by this really powerful attraction. But here's where it gets really interesting. What happens when you drop one of these compounds into water? Well, the water molecules, they kind of sneak in between that pair and just pull them apart. This whole process is called dissociation, and honestly, it's the most important first step. Because once those ions are free and just swimming around, they're ready for action. All right, so let's get a proper introduction to our two main characters here. First up, you've got the cation. That's the positive one, sometimes called a basic radical. And then you have the anion, the negative one, also known as an acidic radical. Now, you're going to want to keep those names in your back pocket. They are a major clue for what's coming up next. Okay, so now that our ions are all floating free in the water, it's time to pick teams. We're going to give them their team jerseys. And based on what they actually do in the water, we can sort them into two legendary opposing teams. Team acid and team base. And the guy who first wrote the rulebook for this whole game, a Swedish scientist named Svante Arrhenius, way back in 1887. He came up with this brilliantly simple definition. He said, look, if a substance releases a hydrogen ion in water, it's an acid. If it releases a hydroxide ion, it's a base. Simple as that. Game on. So here's the absolute key takeaway. Team acid's star player is the hydrogen ion, H+, like the hydrochloric acid that's in your stomach. And team base's star player, that's the hydroxide ion, OH-. Think of something like sodium hydroxide, which is used to make, you guessed it, soap. This one simple difference is what explains, well, everything. But not all players are equally committed to their team. A strong acid or base, well, that means it almost completely breaks apart or dissociates in water. It just floods the solution with its star ion. But a weak one? It's a little more hesitant. A lot of it just stays clumped together. Oh, and here's a bonus fact for you. A base that's really, really good at dissolving in water gets a special name, an alkali. So, with all these ions just zipping around, we're going to need a way to measure which team is winning, right? Is the solution more acidic or is it more basic? For that, we need a kind of chemical power meter, and it's one you've definitely heard of, the pH scale. Now, the pH scale can seem a little weird at first because it's logarithmic, but trust me, there's a fantastic way to picture it. Just imagine a seesaw, and this seesaw's job is to measure the balance of those hydrogen ions, the H+ ions, in a solution. Right smack in the middle of that seesaw at the number 7, everything is perfectly level. This is what we call neutral. There's a perfect balance of ions. And the classic example of a perfect pH of 7 is, you guessed it, pure water. And this seesaw image just illustrates perfectly how the whole scale works. When you have more H+ ions, the seesaw tilts down toward the acidic side, and that gives you a lower pH number. So the lower the number, the more acidic it is. And when there are fewer H+ ions, the seesaw tilts the other way, toward the basic side, giving you a higher number. So higher number, more basic. Easy, right? Okay, so we've got our two opposing teams. We've got a way to measure their strength. The next logical question is, what in the world happens when we put them in the same container? What happens when Team Acid finally comes face to face with Team Base? What happens is this really beautiful, elegant, and simple chemical reaction called neutralization. The acid brings its H+ ion to the party, the base brings its OH- ion, and they immediately find each other and combine. H+ plus OH-, that makes H2O, water. And what about the other ions that are left over? Well, the anion from the acid and the cation from the base, they pair up to form a salt. The two teams just completely cancel each other out. It's perfect. But hold on, the story doesn't end there. What about that salt they just made? And is there any way to reverse this whole process? Let's take a look at the aftermath of this reaction and a really, really cool electrical twist. Now, you might think that since salts are made from this neutralization reaction, they'd all be, neutral with a pH of 7. But it actually depends on the strength of the parents. If you have a strong acid and a strong base, yep, you get a neutral salt. But if you mix a strong acid with a weak base, you actually get a slightly acidic salt. And a weak acid with a strong base, you got it, a basic salt. It all comes down to which parent was stronger in the first place. Okay, now for that twist I promised you. What if we wanted to split things apart instead of putting them together? Well, we can. We just need a little electricity. The process is called electrolysis, and it's basically using an electric current to force a chemical reaction to happen in reverse, to decompose something. And if you do this to water, you can actually split those H2O molecules back apart. It's amazing. At the negative terminal, which is called the cathode, you'll start to see these little bubbles of hydrogen gas forming. And over at the positive terminal, the anode, you'll get bubbles of oxygen gas. You are literally splitting water back into its core ingredients. And here's the part that's just so cool. Because the formula for water is H2O, right? 2 hydrogen atoms for every 1 oxygen atom. You get exactly twice the volume of hydrogen gas as you do oxygen gas. A perfect 2-to-1 ratio every single time. Man, chemistry is just so elegant. So let's bring this all back home. That sour taste of a lemon, that is literally the H+ ions from the citric acid hitting your tongue. That slippery feeling you get from soap, that's the result of a base reacting with the natural oils on your skin. It all comes back to this fundamental, invisible seesaw, this constant balancing act of ions that shapes so much of what we experience every single day. And that leaves us with one final thought to chew on. We've seen how acids and bases do this constant dance, this balancing act of neutralization. So the question is, what other invisible chemical showdowns and balancing acts are happening all around you? In your food, inside your body, out in the environment, right this very second?